Hello, everyone. In the videos for the early sections of this chapter, Dr. Carosa covered broadcast networks and multiple access protocols. This prepared the groundwork for our discussion about the most common link layer protocol, Ethernet, and its use in local area networks. In this lecture, we're going to examine the technology behind wired local area networks. Specifically, we'll be looking at link layer addressing and ARP, which is the Address Resolution Protocol. We have already studied the network layer addressing for network interfaces. Specifically, we looked at the 32-bit IP address, which is used for layer 3 forwarding. The link layer address is also called the MAC address, MAC for Media Access Control. Other names for the MAC address are the LAN address or the physical address. For Ethernet implementations of the link layer, the MAC address is also called the Ethernet address. The function of the MAC address is to facilitate getting layer 2 frames from one interface to another connected interface on the same LAN. The MAC address is 48 bits long. It is typically burned into the read-only memory of the network interface cards, although it can be settable by software. It is written in hexadecimal. Let's look at this diagram. Each network interface card on the LAN has a unique LAN address. How does this uniqueness happen? The MAC addresses are allocated by the IEEE, the Institute for Electrical and Electronics Engineers. Manufacturers of network interface cards buy a portion of the MAC address space and then hard code a unique number from this address space into each individual network adapter. In essence, each device comes with a registered MAC address. There is a good analogy. Think of a MAC address like you would a Social Security number. The Social Security number is associated to a specific person, no matter how much that person moves around. A MAC address is portable. A device can move the network interface card from one LAN to another without changing its MAC address, because this address is hard-coded. In contrast, an IP address is not portable. The IP address is like a postal address. If a person moves around, the postal address changes. A device's IP address depends on the IP subnet to which it's attached. So how does a device know how to send datagrams to another device, given that it knows that device's IP address? To get that datagram on the wire, the sending device must know the MAC address of the destination device. To find out MAC addresses, the device uses an ARP, or Address Resolution Protocol. Each device or IP node on the LAN has a table that maps the IP addresses to the MAC address of other devices on the LAN. This mapping has a TTL, or time to live, after which the mapping is forgotten. Different operating systems have different TTLs. How does ARP work? Suppose device A wants to send a message to device B. Then device A's ARP table does not have device B's MAC address. Well, device A will broadcast an ARP query frame containing B's IP address using the MAC broadcast address. In hex, this is 12 Fs. All devices on the LAN are listening and receiving this ARP query. If device B recognizes this IP address in the ARP query, it sends an ARP response back to device A. This ARP response contains B's MAC address. A can now place B's MAC address in the destination field of the frame and send the message to B. A will also populate its ARP table with B's MAC address to the IP address mapping until this information ages out using the TTL. But what happens if B is in another subnet? First, A has to determine that B is not in the subnet. It does this by matching B's IP address with its own subnet mask. From previous chapters, you know that a router is required to get an IP datagram from one network to another. Here, we are assuming that A knows router B's IP address, probably because the default gateway is configured on A. For the moment, assume that A knows the router's MAC address. A first creates a datagram using B's IP address as the destination address. Then A adds a link layer header and trailer to create a frame, using the router's MAC address as the link layer destination address. Then A sends the entire frame to the router. But what if A does not have router's MAC address in its ARP table? Then A would first send an ARP query broadcast using the router's IP address as its destination IP address. Once the router has received the message from A, the router strips the frame from the message and determines the egress port by matching B's IP address to its routing table. Now the router will look at its ARP table to see if it has B's MAC address. If B's MAC address is not in the ARP table, then the router will have to send an ARP query and get a reply before putting B's MAC address into the frame. Once the router has B's MAC address, the router will add the link layer frame using B's MAC address as the destination address and forward the entire frame to B. In the next video, we will dive a little deeper into the most prevalent link layer protocol, Ethernet.